Good morning. Let us start our lecture today. So next week, we're going to have the midterm. One, I posted a practice exam online. I'm going to do this exam in one of our classes, either today, if we have time, or next Tuesday. And the midterm will be exactly the same. I'm not saying that it is the same numbers and everything, but the form will be the same. The kind of problem will be the same.
You were doing it in class today?
Either today or on Tuesday.
The actual test?
No, the practice exam. The test will be next Tuesday, next Thursday. Right? Other questions? All right, so let us continue our problem last time. Last time we were set the example. So we have in 2 years, 3 grams of radio active atoms is reduced to 0.9 gram. So find the half-life time t and the decay rate k. All right. So in the beginning, you have 3 grams, and after 2 years, it is 0.9 gram. So we have decay, and so if we call x t to be the total numbers of atoms at time t. All right, so you're gonna have dx over dt is minus kx. This is the equation of the decay of atoms that we learned from the previous class. All right, you have dx over dt is minus kx, and the solution will be xt is x0 times e to the power minus kt. All right. So this is the solution and the formulation for the this is the equation and the formulation for the solution. So after t time, the solution will be xt times e to power minus kt. This is the formula that we have from the previous class. Now we know that in the beginning we have 3 grams, right? So x0 will be 3. All right. Now, how can we compute k and the half-life time? How can we compute k? Yes?
In the original formula, you put in the same numbers that you were given. So 3 for dx dt and 0 for x.
So can you say it again?
Wrong formula. So in the x and t formula, you would put in 0.9 and 2.
Right.
And that would give you good.
Okay, thank you. Can you say at the back of the paper, please? So you know that initially you have 3 grams, and after 2 years, you're gonna have 0.9. All right? You're gonna put this into the formula. So what you have is 0.9 is 3 times e to power minus k times 2. All right? So you replace t to be 2. Right? So here I replace t to be 2 and x0 e to power minus k times 2. All right? So I can find k. I have 0.9 over 3 is e to power minus k times 2. So log of 0.9 over 3 is k is 2k. So k will be minus of 1/2 of log of 0.9 over 3. And k will be 0.6. All right? Okay. I explain again. if you call k to be the rate of decay, then the equation will be dx over dt is minus kx. All right? Now, the solution of this equation that we computed last time is xt is x0 times e to the power minus k. All right? So x0 will be 3 because initially you have 3 grams. After 2 years, you have 0.9 grams, so x2 will be 0.9. You replace t to be 2 here. You have x2 is x0 times exponential minus k times 2. So you have 0.9 is 3 times exponential minus k times 2. So k will be 0.6. Questions? So now how can I compute a half-life? Yes?
Well, we could compute it using the differential equation, or we had a formula from last time that the half-life was the natural logarithm of 2 over k.
Right. Can you say the back of the please? So the half-life time will be T0 is log 2 over k, and this is log 2 over 0.6, and this is 1.2 years. All right? We can use the formula that we had last time, which is log 2 over k. When you divide log 2 over k, you're going to get 0.2 years. Questions? It's clear? All right, so for the next step, we're going to learn thermal cooling. But before going to that point, let us try to solve the practice exam so that you can have an idea of what is going to be in the real midterm one. All right. So I posted the practice exam 1 on Canvas with the solutions. But let us try to solve it in our class. So in the exam, you're going to have these kind of questions. So you have 5 questions. The first 4 question is the first 4 questions will be of 5 points. So if you can finish all of them, you're going to get 20 points, and this is the maximum. If you can do the last questions, you're going to get an extra 5 points. So you're going to get 25 over 20. So these 5 points will be accumulated in the sense that, okay, if you have 25 for this one, and if the next one you have 15, then this is going to the next one. All right. So if all of the 3 midterms you got 25, so you have an extra of 15 points. Right. So the final is 25 points. So for the final, you can just finish 2-3 questions so that you get 10 points. And then the 15 points will be added into your final. And you're going to get 25, which is the maximum. Yes?
I assume no calculators on the exam, correct?
No electronic device. No calculators. No no iPhone, no cell phones, and no. This is a closed book exam, so you're not allowed to bring in books or lecture notes. All right. Other questions? It's good. All right. So let us do practice exam 1. All right. Exam 1. So you're gonna have problem 1, which is 5 points. So the max of this is 20 points. All right, so the maximum will be 20 points, and the first one is 5 points. You're gonna solve dx over dt is e to the t plus x. Right? So, any ideas how we can solve this problem? Yes?
Separate out the T and the, I don't know how we can do that.
Yes? No?
Yeah.
Yes?
I would say separate it to e to the t times e to the x and solve it using separation variables.
Right. Can you sign at the back of the paper, please? So you're gonna separate t and x. So e to the t plus x will be e to the t times e to the x. All right. So then you can use separation of variable. You have dx over dt is e to the t times e to the x. All right. Now I'm gonna divide x to the left and multiply dt to the right. So I have dx over e to the x is equal to et dt. All right. So the first problem is to check if you understand separation of variables. So you know that e to the t plus x will be e to the t times e to the x. So you have dt, dx over dt is e to the t times e to the x. So you multiply dt to the other side and you divide the x here. So you have dx over e to the x is e to the t times dt. Now how can we continue? Yes?
Integrate both sides.
Yes, can you sign at the back of the paper, please? Now you're going to integrate both sides. All right? So what is the antiderivative of 1 over e to the x? Yes?
Negative
Yes, can you sign at the back of the paper, please? So this one is minus of minus e to the x. All right, so the antiderivative of 1 over e to the x will be minus of e to minus x. All right, and the antiderivative of this guy will be e to the t. And then you have e to the t plus c. All right, so this is the implicit solution. Implicit solution. All right. Questions? Now we have to solve for the explicit solution, right? How can we solve the explicit solution? Yes?
Take the natural log of both sides.
Yes. Can you say at the back of the paper, please? Now the implicit solution is this formula. In this formula, you have x inside a function and t inside a function. You don't have the explicit formula for x yet. In order to have the explicit solution, you're going to have to take the log both sides. So you have e to the power minus x is minus e to the t minus c. So minus x will be log of minus e to the t minus c. So x will be minus log of minus c to the t minus c. All right, so I explain again. This is an implicit solution in the sense that you don't have the explicit formula for x. You can continue to have the explicit solution. By taking the log on both sides. So e to the minus x will be minus e to the t minus c. So minus x will be log of minus e to the t minus c. X will be minus of this guy.
Will the exam specify when you want the implicit versus explicit solution, or should we always find the explicit solution?
You can do both. I mean, you can give only the implicit solution and this is going to be fine. But if you want to be more careful, you want to understand it better, you can try to find the explicit solution. All right? But here we have to pay attention to one point. What is it? If I look into this formula, I look into the formula this solution of x, I have to be careful at one point. What is this point? Yes?
The negative instead of the natural log.
Mm-hmm.
So don't you need absolute values around it?
No, here, basically, you don't have, you cannot put absolute value because this is the solution of the equation, right? So you have a constraint that minus e to the t minus c has to be positive. All right? Which means, yes?
Would we get enough points if we didn't include that?
No, for the exam, I don't ask you to check this condition. All right? As long as you know how to solve it, it's fine. But can you sign the back of the paper, please? So you, right? Can you sign the back of the paper? Right? So we have to know that in order to take the log, this guy has to be positive. All right? So this guy is positive, meaning that minus c is greater than e to the t. So the first condition is c has to be negative. And you cannot define the solution everywhere. The solution exists only when t is smaller than log of minus. So in order to make sure that this is strictly positive, in order to make sure that this is a strictly positive quantity so that you can take the log, you have to have minus c is strictly greater than e to the t. All right? Which means that first c has to be strictly negative because e to the t is always positive. All right? Now you take the log and you see that log of minus c is greater than t, and t is we don't need t to be positive, but log of minus c is greater than t, which means that the solution cannot be defined everywhere. It is defined only when t is smaller than log of minus c, right? So you cannot take t to be on the full real line r. You have to have t smaller than log of minus c. But in order to have that, you have to have that c is negative, so that you can take the log of minus c. Questions? But this is something difficult, and I'm not asking you to do it in exam. Questions? It's clear? Now let us. So this is the first question. If you can solve it, which is you get 5 points, and this is not difficult. So questions number 2 is also 5 points. So for the differential equation, below, if the points t0, x0 in the xt plane, in the tx plane, for which the basics existent and uniqueness theorem guarantee that the unique solution exists. You have dx over dt is 1 minus t squared minus x squared 1 over 3. All right. So what is the existent and uniqueness theorem said? So the existent and uniqueness theorem said that given the x over dt is ftx. All right. With the initial condition x at the point 0, when x at point t0 is equal to x0. All right. So if the x over if f tx is continuous in t and x, and then the x of ftx is also continuous in t and x. All right. Then there is a unique solution. All right. It's clear, right? So in this case, the t0 and x0 will be the points that we are talking about here, right? So t0, x0 is the point that we have here. So the existent and uniqueness theorem said that, okay, if you have an equation, dx over dt is ftx with the initial condition, x at the time t0 is equal to x0, right? So suppose that ftx is continuous in t and x, and the x ftx is also continuous in t and x. All right. Then there's a unique solution, and in this case we have to find t0 and x0 so that we can apply this theorem, right? So the first step is what? In this case, the first step is to compute ftx, which is 1 minus t squared minus x squared 1/3, right? So this is a continuous function. All right? This is a continuous function. All right, so this function is continuous because it's polynomial, and you have a fraction which is positive. Now, what is the x of fxt? Anyone else? Yes?
I think it's the partial derivative.
Yes, and what is it?
Oh, sorry.
So I want to compute the x of fxt. What root should I use? Yes? Chain rule, yes. So you're going to use the chain rule, right? So for which function?
So the inside is 1 minus t squared plus x squared, and the outside is just the 1/3.
Can you say at the back of the paper, please? We're going to use the chain rule for the inside, which is 1 minus t squared minus x squared. You're going to take the derivative in x of this kind, right? And the outside is 1/3. When you take the derivative, you're going to get, all right, so this is going to be 1/3 prime, right, times 1 minus t squared minus x squared, and you take the derivative in x. This is the chain rule. You take the derivative of the function outside, 1/3, and then you take the derivative of the guy inside. So the derivative of the guy outside is 1/3, 1/1 minus t squared minus x squared, 2/3, right? But of course, this is not a very precise way of writing. But I just wrote it, meaning that you have to take the derivative of the function 1/3, all right? So this is the derivative of the function 1/3 at the point 1 minus t at the point 1 minus t squared minus x squared. Alright, so but this is my currently not very precise. Now you're gonna take the derivative of the guy inside in x, so you're gonna get minus 2x. Alright, so finally you have minus 2x over 3, 1 minus t squared minus x squared, 2/3. It's clear? So let me explain this again. Here you're gonna have the chain rule. So right, so f will be f of gx, in which f is gx over 1/3, and gx will be 1 minus t squared minus x squared. Right? So the chain rule said that okay, the derivative, the x of f will be will be 1/3 of gx to the power minus 2 over 3 times the x of g. Alright, so this is chain rule. You're gonna take the derivative of 1/3 first. You get 1/3 of gx minus 2 over 3, and then you take the product of that with the derivative in x of g. This is the chain rule. Alright, so after you do all of this, you're gonna have minus 2x over 3, 1 minus t squared minus x squared, 2/3. Yes?
Since you take the derivative of the quantity of 1 minus t squared minus x squared, shouldn't the derivative of that quantity be negative 2t minus 2x?
No, because you take the derivative only in x, so there is no minus 2t. You take only the derivative in x.
Oh, okay.
This is the partial derivative, right? So you have two variables, x and t. If you want to take the derivative in x, you fix the t, and t in this case is a constant. So you just take the derivative in x. When you take the derivative in x, this guy will disappear because it doesn't depend on x. So you get minus 2x. Other questions? It's good. Now, I look into this function. Is it a continuous function? Is this a function, a continuous function? Yes?
It's not a continuous function because you can see that if x was to be 1, it would be discontinuous.
If x is 1, the other one will
And
be...
t is 0.
All right. Can you sign the background paper, please? So this function is not continuous because this is not defined at a point where this is 0, right? So this is not a continuous function. Since the function is not defined, t squared plus x squared is equal to 1. Right? So this function is not defined when t squared plus x squared is 1, meaning that the guy here is 0, right? So which means that 1 minus t squared minus x squared to the power 2 over 3 is going to be 0. So now in order to apply the theorem, what should we do? Yes?
We did restrict the domain of the function.
Yes. Can you sign the back of the paper, please? So in order to apply this theorem, all right? So what you do is you just have to avoid this point. To apply the theorem, to be able to use the theorem, we need to avoid t0, x0, such that 1 minus t0 squared minus x0 squared is equal to 0, t0 plus x0 is different from 1. All right? So if you choose the initial condition such that t0 plus x0 is 1, then this function is not defined. All right? Which is wrong. So in order to use the theorem, you have to choose t0 and x0 such that t0 and x0 is different from 0. Right? Questions? So to answer this kind of problem, what you do is the following. So general method. First, you have to look into the points to the function, right? So look into ftx and the x of ftx, right? Find the points where they are not continuous. Find the points where they are discontinuous. And exclude them from the domain, the set of choices of the domain of t0 x0. All right. So the general strategy is that you look into f, you take the derivative in x of f, and you find all of the points such that this function is discontinuous, and then you just exclude all of them from the domain of the initial condition. Questions? It's clear? So in this case, the function is 1 minus t squared minus x squared 1/3. You take the derivative in x, you get this function. This function is continuous if you exclude the point where t squared plus x squared is 1. Right? So in order to apply the theorem, you want to make sure that this function is defined. When it is defined, it's continuous. So you're going to choose t0, x0 such that t0 minus x0 minus 1 to the power 3/3 is excluded from the set. 1 minus t squared minus x squared to the power 2/3 is different from 0. Right? Questions? Is it clear? Yes?
So our answer, we could just write we need to exclude all points where t naught squared plus x naught squared is not equal to 1.
Right. This is just the answer that you need. So this is basically the answer. Right. So this the second problem is it looks complicated, but what you do is something from calculus 2, where you check if the function is continuous or not. All right. Questions? It's good. So problem, and again for the real exam is going to be the same. Of course, the function will be different, but I'm going to ask this kind of questions. Right, the structure is exactly the same. Right, so the first question is to ask you to use separable. The second one is to check the theorem. The third one will ask you to do an initial value problem. So solve the x over dt is 9x with x3 is equal to 7. This is an initial value problem, all right? So how can we solve this guy, this equation? Yes?
Separate dx over dt to be 9x, 1 over 9x dx equals dt to the integral of this.
Right. This is one good solution, right? Separable is this equation is separable,
Right.
so you can use it. you can use this method. All right, so can you say at the back of the paper? So solution 1, separation of variables. Solution number 2. So what is the solution number 2? And I want to remind you of the second solution because it's going to be used in the next problem. Yes?
Integrating factor.
Yes. Can you say at the back of the paper, please? So integrating factor. All right. So to solve this by the integrating factors method, I'm gonna write it under the form dx over dt minus 9x is 0. All right. So what is the integrating factor in this case? Yes?
Negative.
No. Yes? Yes, can you say the back of the paper, please? So you're gonna look into the coefficient of x, which is 9, minus 9, all right? You look into the coefficient of x, you get minus 9, you take the antiderivative, you get minus 9t, and you take the exponential. And you get exponential of minus 90. All right? Yes?
Can we just separate it anyway? We gotta do that.
Yes, so you can do separation of variables. This is good. But I want to do integrating. I mean, separation of variables is already done in problem 1. So what I want to remind you is the integrating factor because if you're going to use it in problem 4. All right? So now the integrating factor will be chosen this way. So you have dx over dt minus 9x is 0. You look into this coefficient of x. You take the antiderivative, which gives you minus 90. You take exponential, which is exponential minus 90. All right? And then you multiply both sides with this integrating factor. Dx over dt minus e to the power minus 90 9x, and this is 0. All right. Now, what can I say? After I multiply this integrating factor to both sides of the equation, I get a new equation. What can I say about the coefficient minus 9, minus e to minus 90 times 9? Yes?
The derivative of e to the minus 9.
Yes, can you say the back of the paper, please? So here you're going to have the derivative of e to the power minus 90, all right? So you're going to have e to the power minus 90 x prime plus e to the power minus 90 prime x, and this is 0. All right? Now, what should I do? Yes? Product book, yes. Can you say at the back of the paper, please? I'm going to use the product book, right? I have e to the power minus 90 x prime is 0. All right? Now, what is the solution of this equation? Yes?
You need to integrate both sides and then isolate the x.
No, right. Can you say at the back of the paper, please? Now I'm going to integrate both sides, right? So the antiderivative of 0 is c, constant, right? So I have e to the power minus 90x is c, so x is c e to the power 90. It's good? Yes? Where's the paper? All right. Now, so let me explain again. For the integrating factor, what you do is you look into the coefficient of x, you take the antiderivative, you take the exponential of that guy. In this case, you have e to power minus it. When you multiply both sides with e to the power minus 90, you're gonna get one derivative on the left-hand side. You're gonna get e to power minus 90 x prime is 0, which means that e to power minus 90 x should be constant, and the solution is x is c e to power 90. But I have an initial condition. So how can I solve the equation? Yes?
You plug in the values in the initial condition.
Can you sign the back of the paper, please? All right. So you use the initial condition to find the constant c. So x3 is 7, which means that x3, but we also have x3 from this formula is c e to the 9 times 3, and this is c e to the 27. All right? So you compare the two, you have 7 is c e to the 27, which means that c is 7 e to the power minus 27. All right? Now you replace that. You have xt is c e to the 90, and this is 7 e to the power minus 27 e to the 90, and this is 7 e to the 90 minus 27, and this gives me 7 e to the 90 minus 3. This is solution of the equation. I explain again. This is the general solution, and here you have several values of c, right? So you can choose whatever c you want, and this is an infinite number of solutions. With the initial condition, you're gonna have a unique solution. x3 is 7, so x3 is c. I'm gonna replace t to be 3 here. So this gives me c e to the power 9 times 3, which is c e to the power 27. I combine the two equations. I'm gonna have 7 is c e to the 27, so c is 7 e to the power minus 27. Now xt will be c e to the 90. I'm gonna replace this guy here. So this gives me 7 e to the power minus 27, e to power 90. I combine the two power. I have e to the 90 minus 27. So e to 90 minus 27, I can write it like e to the t minus 3. Questions? It's clear? Right, so now here you know how to use the integrating factor, and with the initial condition, you have a unique solution. Without initial condition, you don't have a unique solution because you can change the value of c. Right? So you put c to be 1, 2, 3, 4, 5. This is also a solution of this guy. But with the initial condition, you have a unique solution, and this is the meaning of the theorem that we've learned. If you have the initial condition, and if this function is continuous and the derivative of this function is also continuous, then you have a unique solution, and this is one case of that. Questions? It's good? Yes?
So for problem 3, are we allowed to solve it either way?
You can solve it both ways.
Okay.
But for problem 4, you will have to solve it using the integrating factor. Problem 4. You have dx over dt plus 90x is equal to 3. And now you have to use integrating factor. So you see that in the midterm 1, all of the knowledge that you've learned, separation of variables, integrating factors, initial value problem and the theorem. They're all checked. So solution. Okay, here I'm gonna use integrating factor. Okay, so what is the integrating factor that I have to choose? Yes?
E to the T.
Can you sign the back of the paper, please? Right. So this is this is the equation. E to the tx, and this is 3. In order to find the integrating factor, you have to look into this coefficient, right? So I'm gonna write it down, right? So this is e to the t. Now I take the antiderivative of this guy, which is antiderivative which is still e to the t, right? Take the antiderivative of e to the t, you get e to the t. Now you take the exponential of this guy, you have e to the t. And this is the integrating factor. It's clear? So whatever you have here, you just take the antiderivative, and then exponential of that will be the integrating factor. Questions? It's good? All right, so the next step will be to multiply this guy to both sides of the, yes?
Question. Usually when you take the antiderivative, you end up multiplying the exponent by t. So are we not doing that here because we already have a t here?
I don't understand the question. So when you have, so in the previous case, right, you have dx over dt minus 9x. So the antiderivative of 9x and 9 is 9t. So yes, so in the previous case you have minus 9t because minus 9t, you take that the derivative of minus 9t is minus 9. In this case, you have exponential t, and the antiderivative is exponential t. And you take another exponential, and this is an integrating factor. Now let us multiply both sides with exponential of exponential t. So you have 3 times exponential of exponential of t. Good. Questions? Now I'm gonna distribute exponential of exponential to both. Have exponential, 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 exponential. All right. So I'm gonna distribute exponential of t to the sum. I'm gonna have exponential of exponential of t, exponential, exponential, exponential x, and this is 3 times exponential, exponential. So what is the next step? Yes?
E to the t times e to the t is the derivative of e to the.
Yes, can you sign at the back of the paper, please? So this is e to the t prime. This is the whole meaning of integrating factor. The whole meaning of integrating factor is to change a guy in front of x into a derivative so that you can use the product rule, right? You're gonna have e to the t x prime is 3 times x e to the t. Right? Questions? Now, what is the next step? Yes?
Integrate both sides.
Yes. Can you sign the back of the paper, please? Now, you're gonna integrate both sides. E to the t x is equal to e to the t plus c. Right, so this is the antiderivative. So I don't put the 2 limits because this is just the antiderivative of this guy. And we don't have an explicit formula for the antiderivative of this guy, so you can just leave it there. To find x, you just multiply this back to the other side. So x will be e to the power minus et, e to the power of 3. So this is the antiderivative of e to the t. Right? So now I take the, I have what? I have e to the t prime is 3e to the t. I'm going to take the antiderivative, this guy. So I have e to the t x is the antiderivative plus a constant c. To find x, I just have to divide by this guy. So I have x is e to the power minus et times 3. The antiderivative of e to the t plus c exponential minus exponential of t. Questions? It's clear? All right, so you know, so you see the structure of the exam. You're gonna have to do separation of variables. You have to do integrating factor. You have to check the theorem. And you have to do initial value problem. Right? So basically you have 4 questions. And the last question is going to give you another 5 points. If you can do the last questions, you're gonna get 25 points over 20. And again, these 5 points accumulated for the next midterm and the final exam, because what we do is we're gonna sum up everything. And so if you have extra point even in the homework or in the midterm, it is going to be counted. Right? So what we do is we have 15 points for homework, 20 points for each midterm, and 25 points for the final. If you have extra point in each of the of these scores, it is going to be counted to the total points because you're going to have to take the sum. All right. Now let us continue with problem 5, which is SLAP problem. So show that if u is the function of t, and u satisfy u dx dt plus pt, x is d of u x over dt. Then this is for all function x, for all function. Then u has to be k times exponential dt dt. All right, so this is basically how you find the integrating factor. All right, so suppose that you satisfy this this identity for all function x, so u should be k times exponential pt dt. In the previous case, what do we have? We have dx over dt plus e to the t x is 3, right? This is the pt. So the x over dt, this is pt. X is 3. What we did in the previous exercise was to multiply both sides of this guy with the integrating factor. The x over dt plus e to the t x is 3 times e to the t, and we change this into e to the tx prime, right? Remember that in the previous exercise we have this equation we multiply both sides of the equation with e to the t, so that the left-hand side become a derivative. So in that case, u will be this integrating factor, right? So in that case, I'm gonna replace this by u. I'm gonna replace this by u. I'm gonna replace this by p. So the general equation is given pt. Can we find u such that when we multiply u to the equation, you're gonna get ux prime. And this is what we have, right? So this is exactly this. Right? So here you have u, so this is x prime, right? Ux prime plus px is ux prime. Yes?
In the left side, should it be plus u times pt times x?
Plus, yes. Can you say at the back of the paper, please? Yes, there was a typo. Can you say at the back of the paper, please? All right. So this is a style problem, but it is it gives you the basic theory to choose the integrating factor. Right? U in this case will be the integrating factor. This identity means that when you multiply u to the left-hand side of a first-order linear differential equation, you can change this into one derivative, and this u has to be the u that you have before. You're integrating the coefficient of x, and then you take exponential, right? So basically this is difficult, but it gives you the basic theory for the practical method that we have from the beginning. All right, so how can we show this? Any ideas? Yes?
Would we be allowed to take that expression for u and plug it into the equation? Would that prove it, or do you want to do something else?
No, I want to see that, okay, suppose that there is a u, such that when I multiply with the left-hand side of the equation, which is this one, I'm going to get one derivative here. And if I have that u, then u have to be of this form. Right? Any u that change the left-hand side of this equation into one derivative has to be of this form. Right? Any ideas how to do this? Yes?
Is the integrating factor e to the p prime of t?
So you have the form of the integrating factor here.
Oh, I didn't know.
Right. But in this exercise, you have to show that, okay, if I have an integrating factor, it has to be of this form and no other form. Yes?
What if you wrote out, using the product rule, what if you wrote out the expression for the derivative of u times x?
Right. Can you say at the back of the paper, please? All right, so to simplify things, I'm gonna do the simplified case in which pt is e to the et, like in the previous example, and I'm gonna generalize it later. All right, suppose that I have pt is e to the t, and we want to find u such that this is a special case, right, of the previous exercise. Let us try to do the special case of the previous exercise so that you understand. And after that, we're going to replace the general case in which p is arbitrary. So suppose that p is e to the t, and you want to find the integrating factor u such that when you multiply u to the equation, right? This is the left-hand side of the equation. You multiply this u to the left-hand side of the equation. I remind you that equation. is x prime plus e to the tx is 3. Now I want to multiply this u to the left hand side of the equation, and I get something like ux prime. And I want to find all of the u such that this happens, right? Now let us try to do it. So we expand, right? At ux prime will be ux prime plus u prime of x. All right? It's good. So so in the previous exercise, I multiply both sides with e to the tx prime plus e to the tx is 3 e to the t, and I transform this into e to the tx prime. And my question is, can I show that this is the only function that satisfies this identity, or there are other functions? This is how we do it. So you multiply a function u to x prime plus e to the t, and you want that to be ux prime, like here. All right? So you're gonna expand. The right hand side you have ux prime is ux prime plus u prime x, and I'm gonna make them equal. Ux prime plus e to the tx is ux prime plus u prime x. All right? I'm gonna expand on the right hand side. I have ux prime plus u e to the tx is ux prime plus u prime x. All right? So what can I see from this equation? Yes?
U prime should be equal to u e to the t.
Yes. Can you sign the back of the paper, please? So I'm gonna eliminate this guy. All right? Because that's the same. So I have u e to the tx, u, this guy, u prime x, which means that u e to the t has to be u prime. All right? Good. So I explain again. In the previous exercise, what I did is I found the integrating factor, I multiply both sides with the integrating factor, and there is one miracle, which is when I multiply the integrating factor to the left hand side of the equation, the left hand side of the equation will become a derivative like this. All right, so my question is, I want to find all of those integrating factors if it's possible. I'm gonna call this to be u. And what I want is, when I multiply u to the left-hand side of the equation, I'm going to have ux prime, right? So like here you have e to the t, x prime plus e to the tx is e to the tx prime. All right? But this is only one function. I want to find other functions. Now I want to find u. So what I do is I'm gonna expand ux prime using the product rule. So ux prime will be ux prime plus u prime x. I plug it to the right hand side. I have ux prime plus e to the tx is ux prime plus u prime x. I expand the left hand side. I have ux prime plus u e to the tx is x prime plus u prime x. All right. I see that ux prime is equal to ux prime. So u e to the t is u prime x. I can remove x. So I have u e to the t is u prime. So how can I solve for u? Yes? You take the antiderivative of both sides, no? Because here this gives you u, but here you cannot do anything. Yes? Yes. So can you sign the back of the paper, please? So this is basically an equation where you can do separation of variables. Right? So you have u e to the t is u prime, which is du over dt. Right? So you have du over dt is u e to the t. This is separable. Now I'm gonna divide u to the left hand side and t. I multiply dt to the right hand side. I integrate. All right. So the left hand side will give me log of u, and the right hand side will give me e to the t plus c. All right. So the absolute value of u will be e to the t plus c. All right. So but the absolute value of u, which means that u is plus or minus this guy. U is plus or minus e to the c, e to the t. So I can put the previous quantity to be k. So ut will be k e to the t. E to the t. All right. So which means that the integrating factor has to be of the form k e to the t. In this example, we choose k to be 1, but all of the integrating factors will be of the form k e to the t. So it can be e to the t, 2 e to the t, or 3 e to the t. Questions? It's clear? All right, so now let us go to the general case. Right, so the general case will be with now pt. Right, so so you want to find u, general case. So you're gonna find u such that u x prime plus p u is equal to u x prime. All right, and you do the same, right? So you expand the right hand side, so you have u x prime plus px, u px, and u prime x plus u x prime. You remove this guy and this guy, so you have u px is u prime x. You remove x, so you have up is u prime. All right, and you do the same, right? So you have u p is du over dt. So du over u is p dt. So you integrate both sides. P t dt. All right, and then you get this solution. U is k e to the pt dt. All right. So this is the general theory for integrating factor. You have to find a function u such that when you multiply to the left-hand side of the equation, you get u x prime. And this is what I wrote here. So how do you find u? You just identify the both terms. So you have u x prime plus u px. Here I'm gonna develop this into u prime x plus u x prime. Right? You remove u x prime, you get u px is u prime x. You remove x, you have up is u prime. You have to solve this equation to find u. But this is a separable equation. You divide u to the right and you multiply dt to the left, so you have du over u is p dt. So you integrate, so log u will be the antiderivative of this guy, so u will be k time exponential of the antiderivative of pt. And this is the theory behind the practical method that we were using to solve equation using integrating factor. It's clear? Questions? So basically this is the style questions, but this is not extremely difficult. It just requires you to do some extra thinking to see if you understand all of the materials. So it's not difficult to get the 5 extra points. And if you get it, it's gonna be accumulated because we're gonna sum everything. We're gonna sum 15 of the homework, 20 of the 3 midterms, 25 of the final, and you get 100. All right? Questions? It's good. So yes, so this is basically the form of the the form of the midterms. So I recommend you to look over it during the weekend, and if you have questions, just ask me, and I'm gonna answer all of the questions on Monday, on Tuesday. All right, so let us continue our lecture. So let us do thermal cooling. So 1.8.3 thermal cooling. All right, so suppose that you have an object. This is the object. And the temperature of the object is T. All right? And the outside temperature is Q0. Outside temperature is Q0. Right? Suppose here, for instance, the object can be ice. Or a glass of hot water. So let me let me say this is a glass of hot water with temperature T. This is small. So temperature T, and have a glass of hot water. Temperature T. All right. So I have a glass of hot water of temperature T, and the outside temperature is Q. So here, for instance, this is 100 Celsius, and here this is 30 Celsius. So what happens if I put this hot water inside this room, and the temperature of this room is 30 Celsius, and the temperature of the hot water is 100 Celsius? What happens? Yes?
The water cools.
Yes. So the water will be cooled down, right? So the water will be the temperature of the water decrease, right? So which means that the temperature of water will be a function of time, right? So T is a function of time. With T0 is T0. Right, suppose that initially I have T0. Right, so I explain again. I have a glass of hot water, which is, and I put it into this room. The temperature of the surrounding environment is lower than the temperature of the glass of the glass of hot water, right? So which means that when I do that, the temperature of the glass of water is decreasing, and this is a function of time, right? And this is a function of time, and the decreasing rate will be so Newton, according to Newton, the rate of decrease, the decreasing rate is proportional to the difference between the two temperatures. So, right? So according to Newton, the rate of decreasing is proportional to the difference between the temperature of a glass of water and the surrounding environment. All right. So we're gonna call this minus K, T0, T minus Q. All right. So, right. According to Newton, the rate of decreasing of the glass of water is proportional to the difference between the temperature of the glass of water and the outside environment. So this is going to be minus K T minus Q0. And we have an equation. What is the equation in this case? So you have a rate of change, right? Which is minus KT minus KT minus Q0, right? But the rate of change can be computed as a
the rate of change is equal to the derivative of temperature with respect to time.
Yes, can you stand the back of the paper, please? So the rate of change is also the derivative in time of t, right? So the rate of change is also dt over dt. Right? So according to Newton, the rate of change is proportional to the difference between the temperature of the glass of water and the surrounding environment. But this is also equal to the derivative in time of the temperature. So basically, you can have an equation. So you have dt over dt is minus k t minus q0. And this is the equation for the temperature of this glass of water. All right. I explain again. So suppose that I have a glass of hot water with the initial temperature T0, and put this into this room, all right? And the surrounding temperature will be Q0. So this temperature is decreasing, and the rate of change, according to Newton, it is proportional to the difference between the temperature of difference between temperature T and Q0, right? So you have minus K T minus Q0, in which K is a constant that depends on the environment. Now, the rate of change is also equal to the derivative in time of the temperature. So you have an equation dt over dt is minus kt minus q0. All right, and we have a differential equation. And what kind of differential equation that we are having? Yes. Yes, and
Separable?
no, it's not separable.
Linear?
It's linear, yes.
Constant output.
Yes, constant coefficient and not homogeneous. Right. Can you forward back the paper, please? So here you're going to have an equation of the time dt over t is equal to minus k minus plus k q0. All right, so which means that we have dt over dt plus kt is k q0. Right? So the equation is dt over dt is minus kt minus q0. This gives me minus kt plus k q0. So I put this to the other side, I have dt over dt plus kt is k q0. Right? So this is first order. This is linear. This is constant coefficient. And this is non-homogeneous. All right. So in this equation, the derivative in time of t is a first order. So this is first order differential equation. K times t. So this is linear. K is a constant, so you have a constant coefficient. And on the left and on the right side, this is not zero, so you have non-homogeneous. So you have a first order linear differential equation with constant coefficient, and it is non-homogeneous. All right. So we're gonna meet again on Tuesday.